So we're going to take what we did in class with the clothesline and we're going to look at how to solve compound inequalities. The first type we're going to look at is the OR. It's important to understand that OR is a union. You take two inequalities, you put them together on the number line, and that's your solution. So a very basic one, x is less than or equal to -2, or x is greater than 3, means that that is everything that is less than or equal to -2 or greater than 3. So any number to the left of -2 or to the right of 3 satisfies this inequality. It's either less than or equal to -2 or it's greater than 3. Okay? Now, we're going to actually solve these. It's going to be very basic, going to be just like solving what we've been doing, just we're going to have 2 to solve instead of 1. All right? So the first one, x minus 4 is less than -7, or 2x is greater than or equal to 12. You solve each inequality separately. So here we're going to add 4 to both sides, and we get x is less than -3. We're going to solve this one by dividing both sides by 2. And we're going to get x is greater than or equal to 6. So our answer is x is less than -3, or, and that's important, you need that or there, that's part of your answer, x is greater than or equal to 6. To graph it, you graph everything less than -3. You graph everything greater than or equal to 6. You put those two inequalities together. Notice that the solution to an OR often looks like two boat oars, right? You see that? Different OR, but that might help you remember it. The graph of an OR will often look like two boat oars, okay? The next one has two two-step inequalities. I'm going to add 14 to both sides. I get 7x is greater than or equal to 14. Divide both sides by 7, and x is greater than or equal to 2. I'm going to solve the next one. Subtract 5 from both sides. 4x is less than or equal to -8. I'm going to divide both sides by 4. X is less than or equal to -2. Okay? So we've got to put the word OR in there. That's part of it. We got to have it. And we're going to graph both of these. Where is the solution of everything greater than or equal to 2? So that's going to be a closed dot at 2. And it's going to go to the right. Where is everything less than or equal to -2? That's a closed dot at -2. And that's everything to the left. So that's what the solution set to an OR looks like. Look at it. You'll see that it looks like two boat oars. Now let's look at one that's a little more complicated, but it's still not too bad. I'm going to distribute the -3. -3 times 2x is -6x. -3 times 1 is -3. Less than -15. I'm going to add 3 to both sides. I get -6x is less than -12. I'm going to divide both sides by what? By what? By what kind of 6? By a -6. Ding, 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 ding. So that means I have to reverse the inequality, and I get x is greater than 2. The next one, 1 minus x is is greater than or equal to 5. I'm going to subtract 1 from both sides. Notice here I have a -x. That is a very easy minus sign to lose. So bring it down. Greater than or equal to 5 minus 1 is 4. Now, this is not isolated. I don't want what -x is. I want what x is. So there is a -1 here, right? I'm going to divide both sides by what? By what? By what kind of 1? By a -1. So what happens to my inequality? Ding, 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 ding. I reverse it. So I get less than or equal to 4 divided by -1 is -4. So my solution set, I'm going to write it over here because it got a little messy, is x is greater than 2 or x is less than or equal to -4. So less than or equal to negative 4, I'm going to put a closed dot on negative 4. I'm going to go to the left. Greater than 2, I'm going to put an open circle on 2 and go to the right. Okay? All right, the second type of compound inequality we looked at was an and. This says or here. It should say and. And is an intersection. What we're looking for is where do the two graphs overlap. Okay? Now, x greater than or equal to negative 6 would be a closed circle on negative 6 and everything to the right. Right? X less than or equal to negative 1 would be a closed circle at, not negative 1, positive 1, would be a closed circle at 1 and everything to the left. Well, those two graphs would overlap between negative 6 and positive 1, right? So we're going to put a closed circle. Sorry, having trouble getting my pen to work here. A closed circle on negative 6, a closed circle on 1, and it's everything in between. These are the numbers that are greater than negative 6 and less than or equal to negative 1. Greater than or equal to negative 6 and less than or equal to 1. Notice an and sort of gives you this line segment. You might almost think of it as a barbell, like a weight that you lift. Your hand would go between the two numbers. An and is often between two numbers. And since the solution falls usually between two endpoints, you can often write it a little more condensed. You can write it this way. We're going to put x in the middle because x is between these two numbers. You're going to put the least number, the lowest number on the left, the highest number on the right, and you say negative 6 is less than or equal to x, which is less than or equal to 1. Now, if you look at this, both of the inequalities are there. This is x is less than or equal to 1, and this is x is greater than or equal to negative 6 because it's backwards, right? So they're both there. So x is between negative 6 and 1. Everything between negative 6 and 1 satisfies that and. Now when you solve these, this is a little weird, a little different. I want you to look at this. This has 2 is less than or equal to x plus 4 is less than 9. So x plus 4 is between 2 and 9, right? And so there's really 1, 2, 3 parts. Do you see that? You've got an inequality symbol, number, expression, number, right? You want to focus on the middle because the middle is where your variable is going to be. And you want to isolate this thing in the middle. So I've got x plus 4. If I want x to be isolated, what do I have to do here? I'm going to have to subtract 4. But the deal is there's not just two sides. There's now really 3 parts. You've got to subtract 4 from all 3 parts. You've got to subtract 4 from the left, from the middle, from the right. Okay? So 2 minus 4 is negative 2, less than or equal to x, less than 9 minus 4 is 5. Notice that x is in the middle, and it's between two numbers. This is an and. X is greater than or equal to negative 2, and x is less than 5. So how you graph this would be a closed circle. A closed circle at negative 2. This would be an open circle at 5, and you would do everything in between. This is everything greater than negative 2, but less than 5. Notice it looks like sort of like a barbell, sort of like a weight that you would lift. Your hand goes in between the two endpoints, the two parts of the end. Okay? Let's look at the next one. Negative 2 is less than 2 times the quantity x minus 6 is less than or equal to 4. Always focus on the middle because that's where your variable is going to be. So in the middle here, I see distributive property. So I'm going to distribute the 2. 2 times x is 2x. 2 times negative 6 is negative 12. I've got my negative 2 on the left, and my 4 on the right, and I've got my 2 inequality symbols, okay? I go back to the middle. You always focus on the middle. I'm trying to isolate x. So the first thing I've got to do is add 12, and I have to add it to all 3 parts, the far left, the middle, and the far right. So negative 2 plus 12 is 10, is less than 2x, is less than or equal to 4 plus 12 is 16. Go back to the middle. I've got 2 times x. What I have to do now, I have to divide that by 2 because I'm trying to isolate x. But I have to do it to the left, I have to do it to the middle, I have to do it to the right. 10 divided by 2 is 5, is less than, those 2's cancel, and I have x is less than or equal to 16 divided by 2 is 8. So this is everything between 5 and 8. So I put an open circle on 5, I put a closed circle on 8, and since it's an and, it's everything in between. We write x in between, we graph a segment between the 2 endpoints. This is x is greater than 5 and x is less than or equal to 8. Okay, let's look at one more. Go to the middle. 1 minus 8x. I've got to isolate x, so I'm going to have to get rid of this 1 first. I'm going to subtract 1 from all 3 parts. Negative 63 minus 1 is negative 64, is less than or equal to negative 8x. Don't lose that minus sign. Is less than negative 47 minus 1 is negative 48. Go back to the middle. I'm trying to isolate x. I've got to get rid of that negative 8. So I'm going to divide by negative 8. That means I have to divide all 3 parts by what? By what? By what kind of 8? A negative 8. So what's going to happen to my inequality symbols? They're going to reverse. So negative 64 divided by negative 8 is 8. That's going to become a greater than or equal to. Those negative 8's are going to cancel. That less than is going to become greater than. And negative 48 divided by negative 8 is a positive 6. Now look, this right here, this is not wrong, but this is weird. We're going to rewrite this. We're going to write the lowest number on the left, then less than x less than or equal to 8. We're just going to reverse it all. This is the typical way it will be written. This is not wrong. This is a little easier to understand, okay? So this is going to be an open circle at 6, a closed circle at 8, and everything in between. Okay, the last thing we want to do is if they give us a graph, how can we write, or what inequality goes with that graph, okay? So here I have an open circle at negative 1, I have a closed circle at 2, and everything between negative 1 and 2 is graphed. Is that an and or an or? That's an and, right? Looks like a dumbbell. Your hand goes between the 2 things. That means it's an and. So we're going to write x in the middle, and x has to be less than or equal to 2, right? Because it has a closed circle over here, and it's less than 2, but then it has to be greater than 1. So we're going to do that. Notice so what I have is 1 less than x less than equal to 2. Both the inequalities are there. This is x is greater than 1 and x is less than or equal to 2. You could even write x is greater than 1 and x is less than or equal to 2. That would not be wrong. The way to write it with the number in the middle is just a little more concise. Okay? Look at the next one. What have we got? We've got 2 rays, right? We've got 2 rays. One going to the left, one going to the right. They look like boat oars. So this is an or. So we're going to put an or. We look at the left one. The left one is, there's a closed circle at 3, and everything's going to the left. So this would be everything x less than or equal to 3. The second one has a closed circle at 9 and goes to the right. So this is everything x greater than or equal to 9. There is not a way to write an or as a cute little one thing like an and. You cannot rewrite an or. You have to use the word or. Okay? All right. Well, we're going to do some practice solving inequalities. See you then.